Let's begin. Today's January 3rd, 2025, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria cards 4, 15, 17, 19, and 20. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. Criteria card A takes a look at our middle digit, the square digit, and the Turing Machine compares it to the number 4. So should the value of square be less than 4? Should it be equal to 4? Or should the value of square be greater than 4? Criteria card B will take a look at our 3 digits, triangle, square, and circle, and the Turing Machine will let us know which one is the absolute largest. Should triangle be the largest? Should square be the largest? Or should circle be the largest? Criteria card C will take a look at the 3-digit solution, and the Turing Machine will let us know how many evens there are. Are there no evens? Is there a single even? Perhaps 2, maybe even all 3 are even. Criteria card D will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E will again take a look at the 3-digit solution, except this time the Turing Machine will let us know a little bit about the structure of the solution. Specifically, there are 3 scenarios. One where the first one is that there are no repetitions, as in the example 125, or it could be that the solution is a double number, as in the example 112, or it could even be a triple number, as in the example 222. Now remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card D. Okay, so the Turing Machine does not approve of my proposal. Notice that in criteria card D, we are adding up the first 2 digits. So 3 plus 1 is 4. 4 is less than 6, but the Turing Machine does not agree with that. So that informs us that it must be one of the 2 remaining possibilities. And that is that the sum is either equal to 6 or is greater than 6. So let's go ahead and type that up in our notes in section D. And we'll say that triangle plus square is either equal to 6 or is greater than 6. Okay, so at this point, since we don't quite know if it's equal or greater than, it really is hard to cross out anything, but let's see. Yeah, because even the smallest of 1 can still be added to a 5, the greatest number, to equal 6. So yeah, actually we don't have anything to cross out. The only thing we can bear in mind is that we're not going to have 2 small quantities in triangle and square. So you're not going to have like a 1-3 or a 2-3, for example. Those all add up to be less than 6. Can't cross them out. We just have to keep that in mind. Let's see, what else? Well, let's go ahead and let's test criteria card E. Okay, so again, the Turing Machine does not approve of my choice. Notice that 314 has all unique digits. There are no repetitions, but the Turing Machine does not agree with that. So we're looking at either a double number or a triple number. So let's go ahead and type that up in our notes in section E. And we'll state that the solution is a double or triple number. So let's see. Is there a way to deduce that it's just a double versus a triple? Well, we know, yes, in fact, we can say that it can't be a triple number because criteria card B requires there to be a maximum, a largest digit. So obviously if it's a triple number, they're all the same, so you wouldn't have a maximum. So yeah, actually we can go ahead and cross out the triple. So we know we do have a pair of digits and then another number. And knowing that we have a maximum, that means that we're going to have a smaller pair. So obviously you couldn't have a pair of fives. That's too big. So remember that lone digit that's the largest cannot be paired up. So we're going to have a smaller pair. And let's see, what else can we test? So that, again, we can't cross out anything, but it is helpful nonetheless to know. Now, what about criteria card C, the number of evens? I guess you could have a pair of twos and a maximum of 4 if you had 3 evens. I guess that's possible. Let's see. Is there anything to say you couldn't have 3 evens? I don't know. Obviously, you would know that 4 would be the largest, but we would know where it would go. Yeah, I'm not sure. Let's go ahead and test criteria card A. Okay, finally something goes our way. We got a check mark. So the Turing Machine does approve of my choice in square a number 1. 1 is less than 4, and since the Turing Machine agrees, it's true. Square should be less than 4. So let's go ahead and type that up, and that's in section A, and we'll say that yes, square is less than 4. And so that means that we can actually cross out 4 and 5. Oops, I'm doing it in triangle. It should be in square. So square cannot be 4 or 5. So let's see. What else? Can we somehow incorporate what we learned when we tested criteria card D? So if it can't be 4 or 5, what can we say? So if I think now we can say, yeah, triangle can't be a 1 because even if you were to add it to 3, it's still too small. I think same thing with triangle 2. It can't be a 2 because if you add it to 3, it's still too small. 2 plus 3 is 5. Now, we can stop at 3 because you can add 3 and 3 to get 6, and then 4, plus 2, 5 plus 1. So at least we were able to cross out a couple in both triangle and square. Well, that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card B, establishing our largest digit. We also did not query to see how many evens we might have in our solution. And of course, it's still outstanding whether the sum is equal to 6 or greater than 6. So as far as it being equal to 6, I guess there are 3 possibilities. Either the 3's will add up where we have a pair of 3's, and that might be possible if you have, say, a single even. Obviously, if you have a single even, there's no way you could have 2 evens add up. So that would, I think that would force circle to be our 4, which is larger than the pair of 3s. That's possible. Or there could be no evens and you still have a pair. It could be 3, 3, 5. So a couple of possibilities there. And let's see, what about pair of evens? Well, it wouldn't be paired up in triangle and square. So at this point, it doesn't seem that you could have a pair of 4s, because remember, you need a maximum. So if you're going to have a pair, it's going to be a pair of 1s, 2s, or 3s. 4s will not work. And so, yeah, do we have a pair of 2s? Let's see. And I guess technically you could still have a pair of 2s and a 4. It could be 4, 2, 2. So definitely lots of opportunities. And then, as we've stated, what could the sum be? Could it be even greater? So let's see. How could these cards interact with each other? Is it possible that square could be the largest? Well, if square were 3, I guess, well, it wouldn't be 3. So, I guess you could have a pair of 3s. It could be something like 4, 3, 3 or 5, 3, 3. They're both greater, but you do have an even. Oh, wait. Of course, square could not be. I apologize. Square 3 cannot be the largest, because then there would be nothing for triangle to pick. And same thing. Yeah, so square. So that's good. We can deduce that square cannot be the largest. Not possible. So it is now a 50-50. And even though circle is wide open, it may be that triangle might be the largest. So if triangle is the largest, that would mean that we're going to have pairs of 2s or 1s. So that's interesting. So that wouldn't work out with triangle being the largest, because if I add anything smaller than 3, that's less. We could have 4, 2, 2 as equal to 6. So that's possible. And then 5, you have some possibilities there. I guess the question is, what's going to be paired up? Which 2 digits? Maybe the sum is going to be greater. So it'd be 4, 3, 3 versus 5, 3, 3, perhaps. And if triangle is the largest. So let's go ahead and try that out. Let's say 4, 3, 3. So let's just verify, is that middle digit less than 4? Yep, I picked a 3. The sum is either equal to or greater than 6. I chose 2 numbers that add up to be greater, and I do have a pair. All right, let's see how that works out. Now the question is, which one is the best to test? Let's see. If I test criteria card D again to see if there's a 6, I don't know if we'd cross out anything. Obviously my sum is greater than. may eliminate some possibilities. Or should I test which one's the biggest? Yeah, let's go ahead and retest criteria card D. Okay, yes, so it does approve of my choice where the sum is greater than 6. So let's go ahead and cross out the equals. And so what can we say? Well, that means that square cannot be a 1 because 1 plus the biggest of 5 is equal to 6. That's too small. But I think that's where it ends because 2 can be added to 5 and 3 can be added to 4 and 5. So we can't cross out anything else. Now let's, I guess, go ahead. Let's test criteria card B. Okay, it also approves of triangle to be the largest. Since my 4 is bigger than both 3's and it's triangle, the Turing Machine confirms that yes, triangle should be the largest. So let's go ahead and type that up. And we'll say that triangle is to be the largest. Or let's actually just say triangle is the largest digit. And what can we say? Well, if triangle's to be the largest, I don't think circle can be 5, because if circle were 5, there's nothing larger for triangle to be. So let's go ahead and cross it out. Let's see, what else? Can circle be a 4? Well, there is a larger digit than 4, that's a 5, but you wouldn't have a pair. You couldn't pair up, let's see, or can you, hold on. Can we cross out the circle 4? Yeah, there's nothing, well, let's see, hold on. Yeah, circle can't be 5 because there's nothing bigger for triangle to be. I guess you could have a 5. Yeah, I guess. Can we cross out the 4? That would force triangle to be 5. And then, yeah, it'd have to be either a pair of 3's or a pair of 2's. And both of those work. Yeah, so yeah, the only way you could pair up the 4's is with triangle, but then it wouldn't be the largest. And yeah, and so yeah, I don't think, yeah, we can't. Oh, for some reason I'm quite hesitant in crossing out the 4. I don't seem to be rationalizing why I can, but it does seem to make sense that you could cross out the 4. Yeah, you wouldn't be able to pair up the 4 with anything, so why would you need it? Yeah, okay, I think I'm convinced. So let's see, what else? Now the question is, oh, I guess you can cross out the 3 in triangle, because 3 plus the largest, 3 would give you equal to 6, and that's not good enough. So yeah, we can actually cross out the 3. And what about this 1? Can we cross it out? I think you can cross it out because what would you pair it up with? Remember, the smallest 2 values need to be paired up. So yeah, it doesn't seem like it could be circle 1. So yeah, we're looking at a pair of 2's or a pair of 3's. And so it's either going to be 522, 533, or 433. Well, let's see. Yeah, and I guess what distinguishes them, I guess it's a number, right? Here you do have, oh wait, no, you can't have 422. Oh, okay, so it seems like the let's see, 433. Ah, okay, yeah, never mind. 433, 522. Let me write it out. So you could have 433, as I do, but you could also have 522 or 533. And they are all different, based on the number of evens. 1 even, 2 evens, no even. It looks like I may have to go to a third round unless I get lucky. So let's see. Thinking back, can we have 3? So, you know what? So yeah, 3 evens is out of the question, right? That would have been the 422, but that gives us a sum of 6. So yeah, so 2 evens, 1 even, or no evens. Okay, well, it's a draw of the luck. Just have to test C. There's no way. I don't think you can deduce it. Let's see. Yeah. 7, 7, 8. Yeah. Let's see. Oh, no. Okay, so we know it's not 433. And I think we are going to have to go to a third round. Well, we definitely know it's a 5. The question is, are there 2 evens or no evens? And so it will be a quick third round. So let's say, what could it possibly be? Yeah, I don't think we can truly deduce it. So let's go ahead and do 522 and let's retest C. There we go. So it did like the 2 evens. So that means square and circle cannot be 3s. And so it looks like our solution is 522. Okay, well, let's go. C was, we'll say that the solution, well, I guess I should have typed it up in the second round, but we'll just say that the solution has 2 evens. And obviously, had we known that there were 2 evens, we know that, you'd have a pair of 2s or a pair of 4s. So, okay, well, let's go ahead and verify that 522 is a solution. Fantastic. Well, how do we do versus the Turing machine? Well, it is a 5 criteria card puzzle. We did 6 tests across 3 rounds. Don't know. I'm just hoping we tie for the win. So we did A, D, E in the first round, and then we did B, C, D in the second, and then C again. And so let's go type that up. Hopefully I committed that to memory. A, D, E. Yeah, I've already forgot. I apologize. A, D, both D and E were incorrect. And then we did B, C, D, and B was correct. I think C was incorrect and D was correct. And then, of course, in the third round, C was finally correct. So how do we do? Wow, we still beat the Turing machine by 1 question. Not sure how we accomplished that. So very fortunate. Let's see. There's some, obviously we deduced E, and I guess we did get B on the first try. So there's some lucky turn of events, but we do our best with what information we're given and discard what doesn't work and keep trying. Well, how about you? How did you solve it? Did you pick any criteria cards, and did you find out anything interesting along the way? Please add your thoughts to the comments. If you liked the video, please do give it a thumbs up, and of course, don't forget to hit subscribe. Well, until next time, have a great one.